for all the angles that equal to angle number 1. And I'll show you how I did this question. So first, using the vertical angle theorem, as we would see, there's two lines, QB and CD. They intersect each other, creating the opposite angles, and therefore that would match the meaning of the vertical angle theorem right here, as I made a little model. So the vertical angle theorem is our angles that are opposite to each other, formed by two intersecting lines, and those angles are congruent. So that perfectly fits the situation. So we first know that angle 1 equals number 15. Second one, angle 1 equals number 12. So as you can see here, I kind of made this picture. I kind of create a little figure here. So if you see if you make QB and DP, because you know that it's a parallelogram, so it's parallel to each other. The lines are parallel to each other. So, and as you put QB and EP as two parallel lines, but you would intersect CB in them, that would form a situation as we talked about in the last page. So it's one line intersecting two parallel lines. We know right here that 1 and 12 are corresponding angles. So we would say that angle 1 and angle 12 are corresponding. Move on to other possible angles. I also wrote that angle 12, as it already equals to angle number 1, would equal to angle number 9, because I did it in a different angle. So when angle DC, we know that angle DC is parallel to angle AB, as you would see, and I kind of extended line ED to EP to make it more clear. So so the two parallel lines has been intersected by line EP, and angle 12 would equal to angle number 9 because of the alternate interior angle theorem. Move on to the next one. Angle 12 and angle 7. So why would that happen? Same thing as it did. So still DC, AB intersected by line EP, which is a little model here. Angle 12 and angle 7, as you can see, are corresponding because they share like the same location right here and right here. Yes, and also angle number 9 and angle number 7, they have a relationship itself, as you can see. Just like angle number 15 and 1, they are vertical angle. They're opposite angles. So the vertical angle theorem also applies. Move on to number D. So that's when angle 1. Why would angle 1 equal to angle 4? Let's look at this question in a different perspective. Angle 1, angle 4. Let's go this way. Wow. CD and AB, we know that they're parallel, as it has been intersected by line QB, as I've drawn right here. So DC, AB, and QB. Similar situation, two parallel lines intersected by one straight line. The alternate interior angle applies, which makes angle number 1 equal angle number 4, because that's a pair of alternate interior angles. Yeah, and that's basically my explanation of the question. I would say the key to this question is to utilize the model we've covered in class, the two parallel lines intersected by one straight line, and you gotta change perspectives, because sometimes because the intersecting line and the two parallel lines may differ, because there's two pairs of parallel lines and angles are on different sides. So you have to make sure when you prove that which lines are parallel and which intersecting lines to the parallel lines apply to each proof. And that's like the most challenging part of the question. Thank you for watching, guys.